In this video, I will demonstrate the process behind making the CTR prototype. These are the uncured resin tubes that were used. So the first step was to place the tubes inside their corresponding molds. This process was repeated for each mold. Next, they were placed in the photocentric curing machine for 30 minutes and covered with a glass beaker to make them more secure. Again, this was done for each tube and mold. After 30 minutes, we had our fully cured and curved tubes. They appeared to have held their shape well after being removed from their molds. Some tubes did not work out as well. Tube B, for example, was cured with a bend in it. This caused it to snap at the bend after applying some pressure. Tube A was unable to hold its shape after being removed from the mold and having some pressure applied. The smaller tubes, tubes A to C, did not hold their shape that well. After being straightened out and let go, they did not return to their exact original shape. Since the tubes could not maintain their shape, and therefore their assigned radius, the radius values became obsolete. So I decided to cure tubes A through C in various molds. For example, I cured tube A in mold C and tube B in mold D. This resulted in the tubes having a nice variety of curvatures, which I could pick from to create the strongest prototype. So I started putting the tubes together just to see how they would work with one another, and how easily they moved in and out and rotationally. To see whether they would all fit into each other, I combined all the tubes. I then started working on the manual actuation using what I could find in the lab. I found a cable wire that fit into tube B, which gave it forward, backward and rotational movement along its axis. I also found a plastic tube that fit into tube C, so now I had control over two tubes, B and C, and 2 degrees of freedom per tube to work with. After properly bonding the tubes together using a powerful adhesive, the prototype was ready. It was made up of tubes A, C and D. Tube D did not need actuation, as it only held the other tubes in place. The prototype measures 11 centimeters when the tubes are telescoping out, and 4 centimeters when the tubes are telescoping in, almost tripling in length when stretched. The actuation design can be seen here. The clear tube causes movement in tube C, while the orange wire moves tube A. Twisting the clear tube results in rotation in tube C, and twisting the orange wire causes rotation in tube A. I wanted to visually test the accuracy of the prototype, so I designed a small track. The objective was to tip over the screw without knocking down any of the grey tubes. Some of the attempts did not work out as well. I have added an original clip, not sped up, so you can see the true time it takes to reach the objective. And that is it for this video. Thank you for watching as I built my MR Safe CTR prototype.